All right, guys, so what we've been doing lately is we've kind of moved on to 3D figures, right? Three-dimensional figures. And we mainly focused in on prisms, right? We've done cylinders. But bottom line is when we were dealing with 3D figures, we were talking during those times about how many of those would fit inside of the figure, right? And that's a measurement of what's called volume, the space inside. Okay? Today we're going to continue on with three-dimensional figures. We're going to talk about prisms, but we're going to talk about something called surface area. All right? So, when we talk about surface area, I want to just pause for a second, and I want to just show you guys this right here. Now, if I was to ask you to find the area of this, okay, let's just say that all of these are perfect squares, and each length is, let's say, 2 inches. All right? And that is what you'd call a composite figure, meaning it is a bunch of squares all kind of side by side. So if I asked you to find the total area, you would say, oh, well, this is of course a 2 by 2 square, so that's 4. And if they're all congruent, which they are, it'd just be 4 plus 4. You just add up all the 4s, all the area, and to get the total area. Okay? Well, here's what we're dealing with today. We're taking, you can think of it this way, not that this is exactly accurate, but it's pretty close. You could take something like this, and what we're dealing with today is we're taking this composite figure, and we are creating, you could think of it as folding it up into a three-dimensional figure. So the bottom line is you can actually find out the surface area, which is the area of all of these outside squares, exactly the same way. Find the area of each one, add them up. Okay. Now, as an advanced class, I'm actually going, part of a 7th/8th grade standard is to show you a more efficient way than to find the area of all of them and add them up. Okay, and that's what I'm gonna do for you guys today. All right. So, talking about surface area, that is, of course, the main concept, and that is our first word in our vocab. So, surface area, everyone.
Surface area.
So here's what your book says surface area is. It's the sum of the areas of all the surfaces, okay, or faces of a three-dimensional figure. Okay, so it's exactly what I just said. All right, that's what the book says. The sum of the areas of all the surfaces or the faces of a three-dimensional figure. So right here you can just put all of the outside of a 3D figure. Say the area of all of the outside of the 3D figure. In years past, I would say kind of to know the difference between volume and surface area, I'd say, well, if you're going to a birthday party and you're using an old-fashioned box, the volume would be the size of the gift that you could put in the box. The surface area is how much wrapping paper you need to wrap the gift, okay, covering 2 different parts of that. Okay, so volume is the space inside, surface area is that what is covered on the outside. All right, so that's the difference between the two. Now I'm going to show you guys a couple of other things, and according to the definitions, they may or may not make sense. That's okay. We're going to talk about it here in a second. Okay, the next one is lateral faces. Everyone?
Lateral faces.
So here's what lateral faces are. It says the lateral faces of a prism, cylinder, pyramid, or cone are all of the surfaces of the figure except the base or bases. Okay, so I would show you using this, but it's being a cube, it'd be kind of hard to understand. It's probably a little easier to understand this by me kind of quickly drawing a triangular prism for you. Okay, now a triangular prism gets its name off of its bases, right? The bases are the triangles. If you take a look, lateral faces are all the faces or the surfaces except the bases. So basically, it's not that, and it's not this other side. The lateral faces would be this one right here. It would be this side that we can't see there. And on this triangular prism, it's the bottom. So it's all of them except for the 2 bases. Okay, and on a prism, that is, right? Prisms have two congruent bases, parallel bases. Okay, so the triangular prism, those are the three lateral faces. Okay, now the next word kind of goes with that. Lateral area, everyone.
Lateral area.
So here's what it says. It says the sum of the areas of the lateral faces of a solid. So basically what it is, it's the surface area of the lateral faces. That's what lateral area is. It's a sum of the areas of all the lateral faces of a solid. So go ahead and put that down. Capital L equals capital H times, capital L equals lateral P times lowercase h. Lateral L equals, did I say that right? Capital L equals capital P, I don't know why it's so hard for me to say, times lowercase h. All right. All right. Go ahead and take your book, flip over to page 605. 605. All right, so on page 605, okay, let's take a look at number 1. You actually don't have to write this down because this isn't even part of your homework, but I'm going to use it because it's a very basic problem to explain surface area and show you a couple of the different ways to find out how to solve for the surface area. Okay, so they have a rectangular prism, kind of looks like this. It says this is 10 inches, this is 8 inches, and this is 3 inches. Now, I just taught this lesson to my Math 7 class, okay? Now, the concept of this, like I was just showing you with this, okay, this is how I taught them. I'm not going to take the time to do it all, but here's what I taught them. A rectangular prism has 6 sides, and I taught them that they could number 1, 2, 3, 4, 5, 6. And what they're going to do is they find the area of all 6 of these sides or surfaces. And then at the very end, after they got them all, we'd add them together. Okay? To get our answer. All right, and that's it's a good way to do it. It's the whole concept of surface area, find the area of all the surfaces and adding them together, and that's great. And it's not a waste of time to teach that, okay? However, here is what I want to show you guys. This is a different way to do it, all right? And this is more of an 8th grade standard to find out how to solve this using your lateral area, okay? So, here's what you're going to do. On a rectangular prism, it's a little more tricky because the bases, they're rectangles, so every single side has a twin parallel congruent base to it. So I can consider this and this back side a base, or I consider the top and the bottom a base, or I consider the right side and the left side a base. It doesn't matter. Okay, what I want to make sure I do though is I'm very consistent and I find my bases and identify them. Okay, so if I take a look, I'll just say this front here and that back side over there, I would shade it in if I could. Those are my 2 bases. Okay? Now here's what that means. Okay? We had, if you take a look in here, I am going to find the lateral area. And I'm going to use this formula here. Now that probably looks just completely like you have no idea what that means, right? Well, that's why this is a lesson. I'm going to show you. So we have a capital L equals a capital P times H. Okay? Now, here's what this means. Just where you know, this is the lateral area. And to be able to find the lateral area, here's what you're going to do. You are going to find the perimeter of the base, and you're going to multiply it with the height of the figure, or the third dimension of the figure. It might not be the height, it's just the third dimension. Okay? Now you might be saying, well, Mr. Wilkins, okay, but why are we dealing with perimeter right now? Well, here's why. Let me show you guys. Let's say, out of this right here, let's say, I'm going to have a hard time here where you got to use your imagination, that side and this side of the bases. If I found, take a look, if I found the perimeter of this base, look what I'm really finding. If I undo this a little bit, I'm finding how far it is here, 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 and here. And when I unwrap that, it's the length of that. This here is the same length as that. So what I'm really finding is I'm finding one of the dimensions to all four. I'm finding one of the dimensions to all four of the other sides in my rectangular prism. Let me show you again. Okay? See if I can do this. If this is my base, I'm finding the perimeter of my base. And if I unfold it, this side here is the same length as that side. That side there is the same length as this side. This side is the same length as that side. And that, of course, is the same length as that. So when I unfold it, it gives me this. Now, let me fold it back up again. Here we go. So my perimeter of my base, right, times the third dimension, times this right here. But look, when I do that, perimeter of the base, look what I'm doing. Length times width, or base times height. I'm multiplying this side with this side. When I do this, it's going to give me the area of all of this right here. So we're actually, instead of saying finding the area of that, the area of that, the area of that, the area of that, and add them all together, we're using a formula to wipe out most of it in one shot. Okay? That's why we're going to use this. Okay? So the lateral area, here we go. The perimeter of my base. So, the perimeter of my base, I'm going to plug it in after I solve it. Here's 10. This right here is 3. So, remember, don't forget, right? Perimeter is all the way around. So, 10 and 10 is 20. Plus these two 3's is 6. So, our perimeter is 26 inches around the outside of the base. I now plug in my height, what they call height, but it's a third dimension. In this case, it's the depth, my 8. Ladies and gentlemen, 26 times 8 equals, my lateral area is 208. What I just did was I found the area of the top, the bottom, and the two sides just by following that right there. Then what I'm going to do is I'm going to turn around, and it says find the lateral area and the surface area. That's what the directions are. So here's lateral area. Now to find the surface area, here's what I'm going to do. I'm going to find the area of my two bases. Now this is one thing that you also need to notice if you want to save yourself some time. Take a look at this Kleenex box. Look at this side compared to its opposite side. Look at this side compared to its opposite side of a rectangular prism. Or look at this side compared to this side. What can we say about opposite sides? They're the same size. They have the same area. They are congruent. So here's what I'm saying. I'm going to find the area of this side here. It's a 10 by 3 rectangle, which is 30. That's the area of that. And what am I going to do?
Multiply by 2.
Multiply by, I'm going to double it. So here's our lateral area. Here's the area of our two bases, both bases. Guess what I'm going to do to find surface area? I'm going to add them up. Lateral area, we end up with 268 inches what? That's the debate, right? This is where we need to be careful. We are not. Are we using this right here to measure? No. We're going to find the surface area. These are squared, guys. We're not using cubic inches inside. We're using squares. 268 squared inches. Okay? So that's what we're doing today. Any questions? When you get the hang of it, it'll be a lot faster. I went into great detail, right, with the whole box and everything else. But you're going to see me. It's going to get a lot faster. Okay? Okay. Here we go. Let's go ahead and let's do, let's take a look at problem number 2. Actually, I tell you what, let's do number 2. Let's do number 2. All right, I'm going to go ahead and flip it over here. All right, so we're going to go page 605, problem number 2. All right, this is a triangular prism. All right, and on this triangular prism, we have an 8 millimeter by 15 millimeter by 9 millimeter by 17 millimeter here. They're all in millimeters. All right, here we go. Step 1. Okay? Write your lateral area formula. Lateral area equals the perimeter of the base times the third dimension by the height. We call it the height. Step star. All right, little reminder here. This is very important. Identify the basis. Identify the basis. In this case, it's the triangles. Bless you. Step 2. Plug the numbers in. So to get the lateral area, I'm going to go ahead and find the perimeter of the base. So it is 8, 15, and what's this right here? 17, right? So you can use a calculator. 8 plus 15 plus 17 equals 40. There's the perimeter of our base. And what's the third dimension? 9. So right, how many layers it is, right? Going back. So lateral area on this one is 4 times 9 is 36 with the extra 0. It's 360. Now, step 3. Find the area, the basis. Remember, this is a triangle, 1/2 base times height. So, here we go. My base is 15. My height of my triangle is 8. So if I go to solve this, you probably can do this mentally if you do it right. 1/2 of 8 is 4. 4 times 15 is 60. However, don't forget, right? That's only one base. We need to multiply it by 2 to get the area of both bases. Now comes step 5. And step 5 is take the lateral area and add it with the area of the bases. So 0 plus 0 is 0, 6 plus 2 is 8, 3 plus 1 is 4. 480. Of course, step 6, we call it step 6 or step star, and that is, of course, put your units in there. It's all in millimeters, so don't forget, and as a matter of fact, put a star by step 6. Don't forget it's squares, squared meters. 480 square millimeters, sorry, millimeters. Now, I just want to point this out. The directions say find the lateral and surface area of each prism. So actually, what they want you to do is they want you to put, we'll put a step star here. This is going to be one of our answers as well. So when you get your lateral area, they want you to put the units on that as well. 360 square millimeters is the lateral area, and the surface area is 480 square millimeters. Okay, guys, questions on that? No? Okay, so surface area of prisms using lateral area.